Welcome back to my channel, everyone. Sweet Tips here, and we've got a little bit of gold that we've set aside, and we're going to do a refining today. This is 14K material that we find at various sales locally. I'm just going to add this to the melt dish now and get a weight on it. We got 148.2. So we got 14K, 148.2. We'll zero to the scale. And I've got some 10K material here. We're going to add that to the dish now. Boom. So we got 61.0 of 10K. What we'll do now is calculate the amount of sterling silver we need to add. 148 times 148.2 times 1.265 is 187.4 grams of sterling. For the 10K, it's 61 grams times 0.635. So we need 38.7 grams of sterling. Total that up, and we need 226.1 grams of sterling silver. If you look down here, we've calculated that we need 226.1 grams of sterling. But instead of using sterling silver, what I've done is I've measured out 222 grams of gold-filled material here. And so what we'll do is we're going to use this gold-filled material to inquart our carat gold for this refine. Just to show you here, let's see if I can zoom in on that. Right there. 12K GF, that's gold filled. This particular bracelet, let's see if I can find it right quick for you. I don't want to take a whole lot of time, but I've verified all these pieces as gold filled. There you can see it says 12K GF. Here is a ring that says gold filled on the back of it back there. And then here's a watch back, gold filled. There's a little piece here that has a tag on it that says that it's gold filled. Show these to you as I put them in here. There's one that says gold filled. So we're going to take all this material, we're going to put it in our container, and now what we'll do, we're going to go out and we're going to inquart this gold with this gold filled material. Here we go. I've got my mask on to do the melt. I'm starting this off by melting the carat scrap completely before we start adding the gold filled material. Carat scrap is an alloy of pure gold, pure silver, copper, and zinc. And now I'm going to bring in the oxyacetylene torch, get it nice and molten. Before we proceed, here I'm going to throw in some borax because I had some of the gold was starting to stick to the inside of the melt dish. So here you'll see I've got some borax here. Add that, and that helps peel those little balls of gold that stick to the side of the melt dish to congeal and coalesce down into the central mass of the molten gold. Here we go. There's a bangle bracelet. Those things are high gold content. Some of those things are up around 4% or 4 grams of gold per 100 grams of material. Here we're going to start adding some more of the bangle bracelets that I've selected to use for the inquartation of this karat gold. And it's important to understand here, gold-plated material cannot be used for inquarting the karat gold. This is all gold-filled material that I've verified as gold-filled. It's a thick coating of karat gold over brass. Gold-plated material is junk metal with just a few nanometers thickness of gold over just junk metal. And if you tried to put that junk metal in with this karat scrap, there's no telling what you'd get or what kind of problems we'd have if we tried to use gold-plated. So once again, gold-plated scrap is not suitable for use to inquart the karat gold. Here I'm putting in a couple more gold-filled pieces. One of them was a pin that was tubular construction. Boom, right there. And it just, it was sealed up. And when I hit the hot metal with it, it popped. It popped some of the metal out of the melt dish. And I just picked it up with tweezers and put it back into the melt dish. Here I just picked up the container and dumped the last few small pieces right into the melt dish. Now we've got everything to melt. We'll throw a little borax in on this. This will kind of cause any kind of skin to move off the side onto the melt dish, off the metal. And now what we're going to do is pick up this graphite stirring rod. You see there's some pieces that are still solid down on the bottom of that pool of molten metal. So I get those up into the flame, and now we're going to stir this up real good to make sure we got a consistent alloy in the metal. I'm stirring it longer than I think I need to, and it doesn't hurt. I don't think we can over stir, but we might be able to under stir and not get a consistent alloy if we don't stir it long enough. I've probably had this stirring for about a minute and a half now. Now what we're going to do is pick it up, and I'm using the water board in my quench tank here. It's just a board with some water being pumped up onto the top of the board there to keep it cool. And I'm pouring the molten metal onto that wet board. And what that does is it kind of makes the metal spatter as it hits the water and makes nice fine particles that will expose more surface area to the nitric acid when we go to do our nitric acid boils. There's the submersible pump that I use for this. And here's a look at the inquarted gold that we've used gold-filled material to inquart our carat gold. Let's pour the water off of our inquarted gold now. Basically inquarted our gold with brass here. Brass is an alloy of 85% copper and 15% zinc. So what we've got alright, there's our material down there. What we've got is we've got carat gold that's been inquarted with brass. Alright, let's get this material now down into a clean beaker. Try to get it down in here without glass and metal. It's not a very good combination. Got it, I think. Alrighty, we got all of our inquarted gold down into the beaker. Now let's rinse this tap water off with some distilled water, because the next step is to remove the brass with nitric acid boils. And so we don't want any chlorinated tap water in there when we're doing that. Could gum up the works. Here's our material. This is our carat gold that we've alloyed with gold-filled scrap. Gold-filled scrap is a thick coating of carat gold over brass, and it's about 3% pure gold. So for every 100 grams of gold-filled material, we can expect to recover about 3 grams of pure gold. Here I have a list of the reactivity series of metals, and what we normally use is silver, which is way down here. It's alloyed with 10% copper. That's sterling silver. 90% silver, 10% copper, roughly. And that's what we normally use to inquart our gold. But up here we're using zinc. It's way up here in the reactivity series. It's much more reactive than the copper that we normally use and silver. And so what I'm thinking is the alloy in here is brass, which is 85% copper, 15% zinc. So that 15% zinc contact is going to react much more vigorously than if we'd used copper or silver. I'll begin the experiment by adding some distilled water. Put it up to about the 200 milliliter level. There's one last look at our material before we start adding the acid. We're going to use nitric acid to pull all the silver and the base metals out of this gold now, and what will happen is those metals will be pulled by the acid boils, the nitric acid boils, but the gold will get left behind. Here I've got some nitric acid. Like I said, I don't know how this is going to react, so I'm just going to put a little bit in here, maybe 100 milliliters, whatever happens. I don't want it to boil over. Here we go. First time I've ever done this, so I'm kind of making this up as I go. One other concern is that we may get some colloidal gold suspension due to the fact that the zinc is highly reactive and will dissolve rapidly out of our inquarted gold. There it goes. Look at that. See, I'm glad I just added a little bit of nitric and not a whole bunch, like we do when we've inquarted with copper or silver. So that's exactly what I expected it to do, bubble up and react very vigorously. We've allowed this to calm down and set for a while. I'm going to put on a little bit of heat, add a little bit more nitric acid. I've probably added about 200 milliliters in here so far. Just going to add another little splash here. Fresh acid going in. I want to add a little bit more distilled water. And the distilled water provides a medium for the base metals to dissolve into. Now what we'll do is we're going to set this up on the heat and let this react in the nitric acid. This is our first nitric acid boil. And now what we're going to do is we're going to pour this off into a beaker here. Now, I don't expect a whole lot of silver, but the carat gold is an alloy of gold, silver, copper, and zinc. So now what we're going to do is just pour this off, get rid of this solution. Like I said, there'll be a little bit of silver in here, so we want to save the solution. Now what we'll do, add a little bit of water here, give it a quick rinse, get some of that junk out of there. And this is how the stuff is looking. Not too bad. You see it down in there? Looks like, I don't know, it's pretty bad right now. But we're just going to keep going with this. What I'll do now is add a little bit of distilled water. Set it back up on the heat. Alright, here we go. We're going to put some nitric in there with it. And and I suspect it's still going to be fairly reactive, especially now that we've got some heat going on in there. So I want to watch out how I add this stuff. Don't want to add too much too quickly. Oh, we could experience a boil over. Let me add a little bit of water to go in there with it, just so we've got plenty of medium for our metals to dissolve into. Alright, this will be nitric boil number 2 with our gold-filled scrap as the inquartation method. So far we're about 2.5 hours into this since we began adding the nitric acid, and it seems to be progressing fairly well. I don't see a whole bunch of gold suspension going on in there like I was thinking might have happened. It does look a lot different than the times that we used silver to inquart the gold. It's going to have a little bit more junk in it. There's probably going to be some tin and lead in here, because gold-filled stuff is notorious for carrying tin or lead. They use soft solder in some cases to try to repair the gold-filled scrap. So we're going to have to be mindful of that as we proceed here. I'm going to add some distilled water. Put it back up on the heat. Now let's add another charge of nitric acid. Getting to the point where you just dump it on in now without having to worry about it boiling over. This will be our 3rd nitric acid boil. This 3rd nitric boil has been on for about 10 minutes. As you can see, we got a nice head of foam on the liquid in there, which means it's reacting vigorously still from the zinc. But I don't see any signs of colloidal suspension, and this is looking real good. This is exactly what we want to see. Nitric boil number 3 is complete. Let's go ahead and pour this off now. Looks kind of soupy, but it's not looking too bad. Yeah, I do see a little bit of colloidal gold powdered black powder gold coming off, just a little bit, which is what I expected to see. It's not a big deal. Now what we'll do is set this back up on the heat, add some more water. See how it's getting a little bit of black powder stuff going on in there. Let me put in some more nitric. This will be nitric boil number 4. I had to switch out electric burners. The other one quit working. These things are getting harder and harder to find, those little single element electric burners. Oh yeah, there's a lot of colloidal suspension of gold in there. I can see it. It looks black. It's falling apart into a powder now. That means we just dumped a bunch of gold into this container here. So let's go ahead and add some more water. It's falling apart and crumbling to a powder, which is going to make the recovery a little more difficult. This will be nitric acid boil number 5. Here we go. We've got the gold boiling in our 5th nitric acid boil. I think we've pretty much got everything to dissolve now. If you notice, the gold is has fallen apart and has formed a brown powder, which is not desirable. This is very similar to what we'd see if we inquarted with silver and added too much silver. The gold crumbles to a powder. It doesn't hold together like it does when we inquart with silver. It's a powder. I'm just going to pour it in this beaker here. Get some water in there. Cool it down a little bit. It's like a thick shake. See how it's like mud? It's not going to be easy to work with, I'm telling you right now. So this may not have been a good idea to try to do this. Let this cool off. Boy, oh boy. And settle out. Let's see if we can separate this gold mud now. What a deal, man. I thought I was gonna. I can see purple in there. That means we got colloidal gold. This was not a good idea. And oh man, yeah, this wasn't a good idea at all. Got all this gold, fine colloidal gold that we've got to deal with now. What a mess. What a difference a good night's rest can make. That large beaker back there had some gold poured off into it. Looks like it settled completely. This beaker with our powdered gold in it has settled out nicely. And we've got this third beaker back here that's got our that we did the reaction in with the boiling nitric acid. And so now what we're going to do is I've got a vacuum bottle set up down here. And what we'll do is, let me work with this one in the back first. Get this guy out of the way. Doesn't that look excellent? Settled out nicely. Get him up here out of the way. I'm going to pull this big one up first. And I've got my vacuum on. We're going to pull this solution now. Let me see if I can tilt this just a little. Now what we'll do is transfer this blue liquid into a clean beaker. I'm going to save it because it will contain some silver. So let's transfer this now into this clean beaker. Get this out of the way. And now what we'll do is set our vacuum rig back up. I did draw a little bit of the gold up into this, just a little, not much. That's okay. Now what we're going to do is set this back out of the way. I'm going to pull this one down now. And we're going to work on this one. Draw the liquid off of here. First we'll draw the bulk of it up with our coarse tip. Now let's see if we can take this off. Use the fine tip now. See if we can get the rest of this liquid. I've got the liquids drawn off of here. What we'll do is put these things up, get these out of the way. Let's do this. This is the bulk of our gold in this container here. See that brown mud down there? Is the gold. This is our main reaction beaker. It's still got gold in it. And what I think I'll do now is transfer the little bit of gold we got back here into this beaker. There you can see that's the gold down the bottom of that beaker. So now let's get it out of this big beaker and down into our small one. That won't be very much. It looks like a lot, but it's just a fine coating. But we might as well include it to increase our yield. And we're going to add this back into our main solution. Gold mud. See that? Let's look down in there. Get a good view of that. It's just gold powder, mud. Should have all the silver and the base metals out of there now. What we'll do is just add this right into our main beaker without making a mess, hopefully. It's like molasses. See purple. Purple is colloidal gold. I think what we'll do now is add some distilled water. And we'll set this up on the heat now. And give this a quick boil. See if we can get this stuff to settle out for us. Ooh, doggy. Well, at least we got a route to go to get this thing refined. So I'm just going to let that boil. Let's take a look at this thing over here. I don't know if you can see that purple color on the side of the beaker. That's gold. Purple is the color of gold. This is the solution that we just drew off. It's going to have copper and some silver in it. I'm going to draw a little bit up into a beaker here. And we're going to test and see how much silver we have. Got some hydrochloric acid. I'm going to put a few drops in here. If there's silver in here, we should get a precipitate forming of silver chloride. There you see it. That's silver chloride forming in our solution. This verifies that we have silver in our solution. Both of these solutions will have a little silver in them, but they'll also contain some free nitric acid. So the best thing to do with these is set these aside. I'll combine them, set them aside, add some sterling silver in here, and allow the sterling silver to react with any excess nitric that's in here. And then we'll recover the silver out of these solutions after we've performed that reaction. Here's the test that we just did. Indicates a little bit of silver chloride, not much, in these solutions. So that's what we'll do, add some silver and consume the excess nitric in both of these solutions. I've allowed this to boil for, probably an hour now. It's just kind of gently boiling on there. I'm going to pull it down off the heat now and let this cool down and settle. This has been allowed to settle for about an hour and a half. Putting a marker underneath here to tilt the beaker. Now we're going to reach in here and draw off the liquid with our vacuum bottle. We're ready to start the refining now. Add some heat to our hot plate. We're going to begin with this beaker. This beaker's got some residue in it. And what we'll do is start by adding a little bit of hydrochloric acid to this beaker. Nitric acid. I'm going to add a squirt of that in here to form aqua regia. And what we'll do is we'll put the lid on this, and as this heats up, it'll dissolve the gold that's sticking to the inside of the beaker. Now that we've got the beaker cleaned out with the aqua regia, I'm going to set it off to the back, get it out of the way, make some room. Now we're going to take some hydrochloric acid. Hydrochloric acid is the same thing as muriatic acid. It's two names for the same acid. We're going to add about 600 milliliters to our beaker with the gold in it. You see that purple color, that's the gold. And now what we'll do is swirl it around a little bit. I'm going to set it up on the heat. And then we're going to take some sulfuric acid and add sulfuric acid. We've used gold-filled scrap. Gold-filled scrap is notorious for containing soft solder. And soft solder is made from lead and tin. And so the sulfuric acid will combine with any lead that may be present in there, form lead sulfate, and then we can filter it out 100%. Now I'll begin to add small doses of nitric acid to form aqua regia in the beaker. I want to do this real slow because this gold is in a very finely divided state. And we do not want to add the acid, the nitric acid, too quickly and cause a boil over. Here I'm adding small doses, 3 milliliters at a time. And each one of those little tick marks represents a 3 milliliter dose of nitric acid going into the beaker. And so far it's looking pretty good. I don't think it's going to boil over on me. And if you notice here in this next segment, you can see the gold down there dissolving as I add the nitric acid. But the burner started to go out on me, and I started losing heat because that electric burner began to fail. So that's why the reaction's slowing way down. Had to reconfigure and switch burners. This one gave out on me. And so let's turn this off now. This has been boiling in here for about a half hour. I think I've got everything to go into solution. I don't see any more gold in there. So what we're going to do is pull this down off the heat now. Let this cool off and let it settle. Now I'll add some ice to dilute, cool, and precipitate out any silver chloride that may be present. We got it's about 20 after 6. So let's see how long this is going to take to pull through this filter. I've set up another funnel over here because this one's slowed way down. Time is 8:30. I've been at it for 2 hours now. This is just pulling a few drips per minute. Might move some of that liquid over to the other funnel to speed things up. I've shut off the vacuum to this flask. If you look up here, I've still got plenty of solution that has to be pulled through. So what we're going to do is put this funnel on this flask. Set this in the side. This one's complete. Pulled the solution into this flask, so now I'll shut off the flow here. And we'll transfer this into the fume hood here. Just get it up out of the way for right now. Now we're going to take this one over This is the one that's been pulling real slow. I'll set that up over here. Turn the vacuum on. And continue to pull this through little by little. Now we'll set up a fresh filter flask with a brand new funnel flask arrangement. Turn the vacuum on for that funnel. There we go. Now what we'll do is we'll start refiltering. Start all over. Gotta pour this back through the fresh filter here. See if we can get some of that cloudiness out of here. Alright, that one pulled through very quickly. Now I see why. Filter paper failed right there. What a deal. What a deal. Had the vacuum set too high. That's why that filter paper failed. So now what we'll do, install another filter paper. I've got the vacuum limiter on right now, so it should get up to about 7 inches of vacuum and then stop. Now we'll go ahead and start pouring this through this filter. Alright, let's pull this down now and start working with this solution. And this is the funnel with the junk in it. We'll put that in our paper storage. I'm just going to get it out of the way for right now. And now we're going to start pouring this solution through this filter. I think we've got this flask as full as we can get it now. So what we're going to do is take this off of here. Clean flask. Let's move this guy up, back up out of the way. See how cloudy that is still? It's been through the filter at least twice. Pour it through a third time. This is as good as it gets. Now we're going to add this solution here to the beaker over here. It's getting late. I'm getting tired. And this is when mistakes happen. Finally got everything pulled through this filter. So now what we'll do is transfer the solution into this beaker. That's as clear as we're going to get for this run. Here's our solution that's been pulling through the same filter now for 4 hours. It's about 10:30 right now, so we've been at this for 4 hours. I'm about ready to call it a night here. Keep this pulling through until we get all of it out of there. In the meantime, I'll add this to our beaker. And we're going to precipitate some gold now using stump out sodium metabisulfite. Here we go. Add a spoon of it in right now. One, 2, 3, 4, 5, 6, 7, 8, and 9. That should just about do it for us. Finally got everything pulled through this filter. So what we'll do, I've been at this now, it's 11 o'clock, so I've been at this almost 5 hours. What I'll do is I'm just going to take this, put this filter over here out of the way. I'm going to add this solution right in. Get this over here. Add this solution right into this jar that we just precipitated our gold in. There should be sufficient SMB in there to get all of this gold precipitated out. I can see it coming out of solution, so we should be good there. Stir this up real good. Now I've got every bit of our gold in this beaker. What we'll do is cover it up and we'll allow it to settle completely. I've allowed the gold to settle completely. Now what we're going to do is pour this off into a waste container. Get rid of this green liquid off of here. Get our gold in the bottom. Here's what our gold looks like down in the bottom of the beaker. Yeah, using the gold-filled scrap to inquart the gold. Made this a very dirty refining. This is hydrochloric acid I just added to rinse some of the dissolved metals off of here. And now before I pour this off, I'm going to let it settle a little bit in this dish. Here's our gold. What I'm going to do now is pour this rinse acid off that I just applied. And the gold is very finely divided, and it's tending to suspend in the liquid. So what I'm going to do is continue to rinse this like this, and then allow it to settle and pour it off. But I'm going to do it off camera multiple times. See, there goes a little bit of the metal over the edge. Now we're going to rinse up a little hydrochloric acid one more time. Like I said, I'll do this several times off camera until we get all the junk rinsed off of our gold. I just poured off one of the rinses. This is what the gold looks like down in our beaker. Now what I think we'll do is I'm going to add some hydrochloric acid to this. Now we're going to cover it up and put it up here on the heat and give it a boil in hydrochloric acid. I've had this on here boiling now for about 10 minutes. Well, the gold looks much different now. Let's take it down here and let it cool off here for a little bit. Let's go ahead and pour this off right quick into our waste container. See, it's got a little bit of color to it. Look at the color of the gold, man. It's really changed. All right, let's see how this looks down in here now. Looks much different. A lot better. Now we'll give this a couple of rinses with some distilled water. That's gonna light off the suspension in there. So what we're gonna do, I guess, is put this down on our dish and let it settle out before we pour that water rinse off. I've given this a couple of rinses with water now. We've allowed these rinses to settle down. Pour off that water rinse. And now what we're gonna do, look at that, man, it looks red down in there now. Now what we'll do is I'm going to add hydrochloric acid to this, about 250, 300 milliliters. There, we took it up to the 300 milliliter level. Let's cover this up, and we're going to set it up here on the heat and redissolve this gold a second time. Let's add a little bit of sulfuric acid, just in case we've got any lead in here. let's add some nitric acid. This will form aqua regia in our beaker and cause this gold to dissolve, go into solution. That's six 3 milliliter doses for a total of 18 milliliters of nitric acid. I'm going to add some more nitric acid now. This stuff is going to be real hot, so I got to add this slow, just a drop at a time. Add it too fast, we could cause this to boil over. Add some fresh hydrochloric acid, about up to the 80 milliliter level. I'm going to add that to the reaction just to make sure that we've got plenty of hydrochloric acid in there to get all of our metal, all of our gold to go into solution. Let's put in a little bit more nitric now and continue to get the rest of this gold to dissolve. You can see that nitric is angry. Can't seem to get all this gold to go in solution. But that's not a bad thing. That's probably a good thing because it means we have more gold in the beaker than we thought. Sometimes it can be deceiving when it's in a finely divided state like that. Looks like there's way less gold than you're expecting. Been out here about a half an hour trying to get that gold powder to dissolve, and I'm not complaining. That's a good thing. That means we may have more gold in there than we thought. I measure out another 80 milliliters of hydrochloric acid. We're going to add this to our reaction back here just to make sure that we've got plenty of hydrochloric acid in here. Sometimes it'll stall if you run shy on hydrochloric acid. Should be getting fairly close to having all this material in solution. So we'll just keep adding small doses of nitric acid until we get that all to dissolve. Let's add a little bit more nitric acid. Just a few drops at a time so we don't bubble it over. pieces are starting to dance. I'm going to add just a touch more nitric here. By dance, I mean the bubbles are starting to levitate the pieces of gold in the solution. Let's add another half milliliter of nitric. Just a little bit here. I had to look back at the record. We started this at 1:30 p.m. It's currently 3 p.m. It took me an hour and a half to get this gold to dissolve. I'm going to pull it down off the heat now and let it cool down. So far, everything I've done here has taken much, much longer than it normally does. Let's add some ice here to speed this up. This ice will cool it. It will dilute it, and it will precipitate out any silver chloride that may be present in our gold. This second refining has cleaned the gold up just wonderfully for us. Now what we'll do is we'll get set up to do a filtering. Even though that solution looks crystal clear, the solution looks beautiful, nice and clear, but that can also be deceiving. Now we're going to go ahead and run it through the filter. Here we go. What a difference a second refining makes. I mean, we've been filtering here about 30 seconds now, maybe a minute. Pretty much got everything almost pulled through this filter. Got a clean beaker here. Just about got everything pulled through this filter. Now we'll get all the color rinsed out of here. Down into the flask. Yeah, look at our funnel. Nice and clean. No traces of contamination in there. Now let's, man, look at that solution. Absolutely gorgeous. Pour it off into this beaker now. adding some ice to keep this solution cool while we do the precipitation. Usually when I have 2 or more tray ounces of gold in solution, I add ice. I ran out of my stump out, so I've got some food grade sodium metabisulfite, and what we're going to do is we're going to add spoons of this now to our gold solution. Precipitate out the pure gold. Here we go. Let's see how that looks. Give this a stir. I can still see a yellow tint, which tells me we need more precipitant. Starting to get that white foam. Alright, I think that should do it. I think we've got everything to go into solution now. Let's stick a piece of filter paper in here. Get some of our solution on it. Stannous test. There you can tell all the gold has precipitated. Here's our pure gold. It's looking real good. Now, on this second refining, let's get rid of this waste solution. Alright, that's what the stuff looks like down in our beaker now. I think what we'll do now is just give this multiple rinses with some distilled water to get all the excess chemicals off. This always seems to help. I'm going to give this a boil in hydrochloric acid. I've had this boiling in the hydrochloric acid now for about 20 minutes. Let's go ahead and get it off of here. I'm going to pour off this hydrochloric acid boil. Let's rinse this with some distilled water. Oh boy. I'm trying to loosen it up down there. Try to break this stuff up so we can rinse it well. Let's get our gold down into our melt dish now. Carefully. Let's get our gold down here on the melt table now. And let's go ahead and commence to melting our gold. Here's our nice pure gold bar that we just melted up. We were looking for a yield from the carat scrap of 111.8, 6.6 from the gold filled material that we used to inquart the carat gold, for a total yield of 118.4 grams. And let's see what we got here. 117.7. Well, that's pretty close. It's only off by about 0.7 of a gram. It's got a little bit of frost on the surface there. But this is a nice pure gold bar. I'm very pleased with it. The dissolve, the nitric acid boils took way longer. The filtering took way longer. The dissolving of our gold for the second refine took way longer. And if anybody ever asks me if we should use gold filled material to inquart our carat scrap, I think my answer is going to have to be a resounding no. Okay, this will conclude the video. Thank you for watching.